Okay, can you hear my voice right now?
Yes, we can hear your voice, sir.
Okay. How many participants do we have? Okay, currently in the meeting 35. Okay.
Hi, good evening, sir.
Hi, good evening. Siapa tu?
Peter.
Eja. Okay. Sekejap nah.
But the chat box is not allowed to be used.
Chat box.
Yeah, there's usually a chat box where we can type in if we want to ask anything for us who are embarrassed to use the mic.
Why, is it because you can't use the chatbot?
Yeah, it says that we are not in the team or
Oh, okay.
we are
So,
not team members of this channel.
Oh, I know, because sir just give us the link. We enter, we can just see the presentation, but because we are not a member, so we cannot chat lah, basically.
because like previous semester, the information from from Yulen is connected seamlessly to the MST team. So that's why your info is in MST team as well. But this time, I think this semester they didn't provide that. So if I want that, I have to key in your name one by one lah, individually. After this, if I want to use the MST team.
Or maybe you can ask Ian, maybe he know how to make a new group, like a new team, so you just give us the invite code, so we just put it in and we can enter the teams, basically.
That's one way. Okay, never mind. If you have any question, then you can just speak up. For now, for now. Okay, so right now we have how many participants? 51, 52. Okay. Keep increasing.
Hello.
Now, test.
How many participants at the moment? Okay, 55. Okay, I think we can start already. Yeah? Can we start right now?
Yes.
Boleh tak, guys? Can we?
Yes, sir, yes.
Okay, yeah? Okay.
Yes, sir.
Yes. Yes.
Okay, so Assalamualaikum and a very good afternoon to everyone. Okay, so this is me, okay, your new lecturers for this semester. So I believe that your last lecture for a previous semester is Madam Noraini, right? Okay, so initially Madam Noraini want to take your group for this coming semester as well, but we got some problem with the timetable clashes. That's why she couldn't take your groups, huh? And that's why I have to take your group for this semester. So I would like to apologize if you still want to use the same lecturers from the previous semester. Okay, so what will be the first things that we have to do for today? So the attendance, okay, first thing will be your attendance. So at the moment, I know that some of you are still having problem with the Power Apps, okay? So if some of you can use the Power Apps, you can use the Power Apps. So can use the Power Apps. Okay, can use the Power Apps. I think we are going to make it mandatory starting from next week onward for Power Apps. Okay, but for this week, okay, I will just take the attendance from the list number for who attend the MST team, and from the link learning satisfaction pool, I will use the learning satisfaction pool. So
Sorry,
make sure
sir.
after this,
Uh,
yes.
I think you should start recording.
Oh yes, thank you so much. I always forgot about this.
It's
Okay. Okay, I record already. Okay. So maybe after this, you guys are not able to get the access for the recording. Then I will share with you in the Ulen the recording video. So someone need to remind me. Yan, maybe you can remind me for the recorded video and for the lecture slide as well.
Sure, but can you guys hear me as of the moment?
Yes, Yan.
Yeah, that's good. I had sound issues just now.
Oh, okay. Okay. As I mentioned earlier, so the attendance, okay, for this week, I will try to use the learning satisfaction pool because I know that we are still having problem with the Power Apps. Okay, but maybe starting next week we can use the Power Apps. Okay, so make sure after we finish our class today, so go back to Ulearn and fill out the learning satisfaction pool. That will be used as your attendance. Okay, so as you guys know already, for this semester, okay, we are going to conduct it online as always. Okay, actually we have to use the BBB. Okay, if any case where we have a problem, then we can use the MS Team. Okay, I also prefer the MS Team actually. Okay, what about your tutorial? So your tutorial, okay, it is slightly different as compared to the other subject. I believe that your tutorial for other subject will starting from week 2 onwards. But for our subject, we will starting from week 3. Week 3. Okay, and you need to know that, okay, for tutorial, we start week 3 and then we have week 4. So for these 2 weeks, we are going to conduct it online. Okay, we have to do it online. So can you guys see my handwriting on the screen right now? I'm writing the week 3, I'm writing the week 4.
He still haven't loaded yet.
Haven't loaded yet.
Yeah, we can only see until the tutorial. That's it.
Tutorial, Okay. I'll try to refresh a little bit here. Still nothing. Okay, but never mind. It will come out after this. Okay, so week 3, week 4 will be online, and you will have to use the BBB. So still BBB. Okay, it came out already. But only for 2 weeks only. Week 3 and week 4. Starting from week 5 onwards. Week 5 onwards, we are going to do it face to face. Face to face. So you will be divided into several groups, okay? But your group will be quite big, because we are using the big venue like LH1, LH2, LH3. It is not like your physics and chemistry, because you will be separated into much smaller group because you have lab and you have tutorial, and each lab and each tutorial will be separated further because the venue is small, okay? But for our tutorial, we are using the big venue. LH1, we are using the LH3, so that's why we have actually, how many groups? One group separate into 2 only. As compared to physics and chemistry, they separate into 4, I think. So starting from week 5 onward, it is face-to-face. I'm not worried about the one that is on campus right now. Okay, do we have the international student here? Do we have international student in this class?
I don't
Anyone?
think there are any.
Nikita.
No, you're not an international student, Nikita.
We don't have any international student.
Don't think so.
Oh, okay. So that's good lah. Meaning that we can have a face-to-face session with no issue. Okay, so that's for tutorials. Okay, what else that we have to discuss? The important things. Okay, for today, I will discuss a little bit on the course overview. Okay, course overview. Although this one have been given already back in Ulearns. Okay, I've prepared a welcoming slides. Welcoming slide. so you guys can have access in Ulearns. Okay, in there I've explained what is the course outcomes. Okay, what is the expected distribution of the course assessment, etc. Okay, and there are one things that I need to mention to you right now. Okay, so for now we are still on 70-30. 70%, 30%, coursework and EA at the moment. Coursework EA 70-30%. Okay, but 30% last time you are doing it online, but this semester I think there is a chance for all of you to do it using final exam. We are not using the EA anymore, but it is not been finalized yet by the Senate. Senate is someone that is higher up in the university, so they haven't decided whether we still want to use the online or we want to use the normal way, the usual way, which is a final exam. So that one is not confirmed yet. Okay, but right now we still refer to this one, the one that you guys have done it already back in the previous semester. Okay, so 70-30%. This is for the course outcome, for the course distribution assessment. Okay, so right now let's talk about course overview first. Okay, course overview. Okay, just quickly. Okay, so what we have right now, we have the CO1, which is I will explain. We have a 5 course outcome. CO means that course outcome, not course overview, sorry. Course outcome. So we have CO1, we have CO2, we have CO3, we have CO4, we have CO5. Okay, so for this we have, wait, I'm using different color. Okay, so to do this simply, CO1 is about integration. CO2, it is about differential equation. CO3, it is about matrix. Okay, although the name in the course outcome is actually linear algebra, but I just refer it as metric for you to make understand easier. CO4, it is about sequence and series, but I just simplify into series. And lastly, we have about statistic and probability. So we have only 5 main things that we need to discuss in this semester or in this subject. So this will be covered throughout 12 weeks that we have, starting from this week onwards. Okay. So before we start with the first CO, before we start with the first lecture for today, let me share with you first. Okay, let's go through the welcoming slide quickly. Okay, I'll show you, share the screen. Wait, I'll share the screen right now. Where is it? Okay, I'll share the screen over here. So can you guys see the PowerPoint slide?
We see, yes, we can see your whole screen actually.
Yes, we see the desktop entirely.
Oh, entirely, okay.
Yeah.
So you guys have seen the welcoming slide already, right? In Ulearns.
I have. Have you guys?
Okay, so some of you might have downloaded already. So, but I'll just go through this quickly. So this slide have been prepared already, so you guys can have a look at it. Okay, but I just go through this quickly. So introduction to the subject FBM 0035 Maths 2. So this is our course code. Last time you are doing FBM 0015. This time it is 0035. That's the only difference. What else? Okay, so again, I would like to say that congratulations for all of you for coming to the next stage of the maths subject. So basically you guys passed already the first stage, which is the maths 1, and this is your second stage, which is the maths 2. Okay, next. Okay, so we have 2 lecturers teaching the subject. So as you guys know already, your previous lecturer is Madam Noraini Jamuddin. So she will take the CE1, CE2, and computer science. So whereas I will take the ME, EE, COE, CVME, PEBG groups. So previously, as I said before, ME, AE, PE, okay, that group belonged to the Madam Noraini, but due to some timetable clashings, I have to take her groups actually. So my number 0134089465. So I believe all of you have obtained my number already. So it is the same number as I contact with you in the WhatsApp group, same thing. And we have my email as well and my office, okay? So as I mean, like last semester, okay, so we can have like a face-to-face session actually, but that one we have to do some booking first because we have to do some consultation in the CFS office. So let me know if you want to meet with me so we can have a meeting, but inform me earlier. Okay, so our teaching team tutorial. So this is the updated name teaching tutorial name list because the one that I gave to you in the ULearn, okay, it is not the updated one. So we have right now 5, 1, 2, 3, 5. So we have 1 girls, okay, and 4 boys, okay. So all of these, okay, I will separate the groups later and will assign the tutors for all of you. Okay, what else that we need to discuss here? Okay, something, okay. Course outcome, okay. This is the same thing as I explained to you before. So course outcome 1, compute integration of function using suitable technique and solve application problem using integration. So simplify that word, okay, easier, integration. So course outcome 2, determine the solution of first order differential equation. Okay, I just simplify it like what I write before. Differential equation. Course outcome 3, it is about matrix. Course outcome 4, it is about series. Course outcome 5, it is about basic statistic and probability of event. Okay, statistic and probability, just simplify it. Okay, so 70-30%. Okay, your coursework distribution, okay, will be more or less the same as Maths 1. So we have a 10% of quiz, 15% for assignment. Okay, 15% for assignment here is separated into 2. We have 10% for assignment. We have a 5% for tutorial. So tutorial will be given marks. And then we have test 1, we have test 2, 20% and 25%. Oh, I forgot to mention to you the date for test 1. Okay, later I'll update to you. But that one is the proposed date first. Okay, so the list of chapters or topics. Okay, so you guys can see that we have 1, 2, chapter 1 and chapter 2 basically cover the integration. And chapter 1, chapter 2 here will be covered for your first test. Your first test will be conducted on week 6 actually. Chapter 3 is about matrix. Differential equation. Chapter 4 is metric. Chapter 5 is series. So chapter 3, chapter 4, and chapter 5 will be for your test 2 actually, for test 2. We have descriptive statistics, and lastly we have a probability. And the last chapter is random variable, but since we are conducting the class online here, so I'm not sure whether we can finish until chapter 8 or not. So subject to changes, if any. Okay, so this is some sort of like a timeline. You guys can refer to by yourself here. So studying from UCampus, so same thing as the other class as well. So make sure you check ULearn regularly for updates, and I will inform to you through your WhatsApp group as well. Okay, for something. What else? Okay, time management is really important. So if there is any problem, okay, make sure to contact me. Okay, or you can contact your tutorials or your tutors, or your tutors can contact me as well. But if anything, if you got any problems, couldn't access, okay, you have anything, okay, might be personal as well. Personal also, you guys can contact me. Okay, so I just want to know that I'm here for you. Okay, so if you have any personal problem as well, because this time around it is quite important, because we have a lot of issues since last semester as well. We have a personal issue, but she or he didn't want to share, but at the end only he or she want to share, then it's quite too late already. Okay, so if you have any problem, just let me know. Okay, I'll try to help whatever I can. So the list of reference books, okay, you guys can have the other material or other resources as well. It's not only everything you can refer to my notes or my lecture site. You can go to anywhere as long as it is related to the topics. Okay, so you guys can do it. Like, I'm not sure whether Madam Aini mentioned to you or not. Okay, but like in maths, actually, it is something like routines. Like integration, differentiations, it's like some sort like a steps. Okay, so when you want to perform any calculation, you just have to know the steps. Okay, so maybe you have a problem, etc., you don't know how to work it out. Okay, you guys can refer to, you guys know already, I'm sure you guys know, you guys can use the symbol lab, okay, to help you actually find out your solution. It's like a calculator, but this time around, instead of giving you the solution, they will give you the working step. Or maybe you can use the photomaths. Okay, or if you want to do the graphing, you can use the Desmos. Okay, you can use some sort of thing that we call it as a GeoGebra. So you guys live in the era of technology, so I'm sure you guys are aware of that, like what Yan have been doing right now by using the podcast. So it is a good way, it is a good alternative. Okay, so you guys can share your thought, everything, etc. So you guys are living in the 21st century, so we have a vast way to learn. You guys have a Khan Academy as well, so we have a lot. We have what else? We have the MIT free MOCC, massive open online course. Okay, so you guys can have the question from there. Okay, so the material here is vast. It is not like our time, my time. Previously, when we want to get something, we have to go to the library. Right now, your library is in your phone. Okay, it's in your finger. You just have to type and everything is ready for you. Okay, of course, but you need some guidance lah. Okay, don't just believe everything in the internet. Okay. Okay, so that is for this part. Okay, let's go back to the slide screen. Okay, wait. I'll share the screen. Share. Okay. Done share. Okay, now can see the screen?
Yep, can see the
Yes.
screen now.
Okay, okay, can see the screen. Okay, so I'll explain first my way of teachings. Okay, so if you are not comfortable with this way, so you guys can inform me. Okay, then maybe I can change it. Okay, so my style of teaching, okay, actually, okay, the notes, lecture notes and lecture slide I've already uploaded in Newlands, so you might want to refer to that in PowerPoints. Okay, but in addition to that, okay, during the class, what I did is that instead of relying on the lecture slide, okay, actually I'm writing everything on this tablet screen. So you can actually assume that this tablet, that the one that you are seeing right now, is like a whiteboard lah. Okay, so I'm going to write everything on this specific page. Okay, maybe there are some contents, okay, taken directly from the lecture slide. Okay, and maybe there are some additional things that I will add here. But don't worry, the lectures here, the ones that I'm doing the handwriting right now, I'll still share with you after every single class. Okay, together with the recording video lah. But recording video by using the Microsoft Stream, I believe that it is going to be immediately. Okay, but by using the BBB, I believe it will be around, depends lah. Sometimes 2 days, sometimes 1 week, sometimes 2 weeks. Okay, it depends. Okay, on the server capability. Okay, so course outcome done. Okay, now let's start with the first chapter. First course outcome, which is integration. Okay, that coincidentally is the same thing as the first chapter, integration. So, can we start? Are you guys ready?
Yes.
Yes.
Okay.
Yeah, very good. Let's go.
Okay, let's go. Okay. So we'll just do only for certain things only for today. Okay. So with that, we can start our first chapter already. So integration, I will write down here. So integration, this is chapter 1. Okay, so chapter 1 and integration here specifically in this chapter, what we need, what it is about. In the first chapter, we are talking about technique of integrations. Techniques of integration. Okay. How to integrate the functions. Okay. So this is the things that we want to discuss in this chapter. Basically, in the first chapter, we talk about technique of integration, how to integrate certain function. So to put it in simple word is that, okay, so you will be given a function, okay, and then you will integrate, and based from that, what is your result? Okay, this is what you want, what we want. Okay, this is our objective for this chapter. Okay, and what kind of techniques, okay, to integrate, everything will depend on this function. What kind of techniques will depend on what types of function that you have. What types of functions that we have? What type of functions that we have? Sometimes your function here is simple. Sometimes it is intermediate. Sometimes it is too complicated. Okay, so depends. Depends on what types of function that you have. Okay, several techniques are going to be employed. Don't worry, I'll give you the guidelines later on. Okay, what kind of techniques that we have to employ for certain kind of functions. Okay, but integration, okay, in simple word again, here we are talking simple things again. Okay, integration basically is a reverse process of differentiation. I'm sure that you guys know already about that. A reverse process of differentiation. This is nothing new. You guys have learned it during your high school day as well. Okay. And since it is a reverse process of differentiation, and one thing before that, I wanted, integration comes from differentiation. Okay, it came from differentiation. That's one thing. And it is a reverse process of differentiation. Okay, when we say that it is a reverse process of differentiation, okay, all formulas that we have for integration actually come from the differentiation. So basically, we just have to use back the formula for differentiation. So you guys have the list of formula for differentiation already. So from that list of differentiation, okay, we can use it for the integration. So it is the same thing. Okay. So for example, when I talk about derivation here, okay, where in the previous semester, in last semester, when you discuss about differentiation topics, okay, you have a lot of formulas, like for example, the product rule, the quotient rule, how you differentiate sine x, you get cos x, etc. How do we get the formula? Already been discussed. How do you manage to get the product rule formula? It comes from the limits, okay? That kind of thing, okay, I believe you guys have, okay, you guys have discussed already in last semester, okay? Something like why we differentiate dx, the sine x, we get cos x here. How do we manage to get that number, that function? Okay, that kind of formula you guys have derived it already. Okay, back during your last semester. Okay. What else? Okay, how do we get the formula for product rule? Do we get the formula for product rule? for product rule, quotient rule, etc. Okay, that one have been discussed in the previous semester. So what we need to do in integration here right now is just to make some alteration, okay, or the reverse process of it already from the differentiation. So there is not much of the derivation. I mean the how to derive the formula for integration, because the derivation formula coming from the differentiation topics. Right now we are just making use of the differentiation formula. Example. So example here, if we differentiate sine x, we are supposed to get cos x. Okay. If we differentiate what else? Cos x, we are supposed to get negative sine x. What else we have? If we differentiate a secant x, for example, secant x tangent x. Okay, so number 1, number 2, number 3. All of this is the differentiation formula. Okay. Okay, from sine to get cos, from cos to get negative sine, from secant to get secant x tangent x. Okay, there is a way. Okay, there is some way. It's not magically. Okay, differentiate sine you get cos, differentiate cos you get negative sine. It is not like immediately you get the negative sign. So there is a process, there is a derivation flow, okay, that give us the result. Differentiate cos, we get negative sign, but that one you guys have learned it already in the previous semester. Okay, so for the integration, okay, from 1 here, we just have to reverse process. So cos x, you are going to get sine x. Number 2, okay, if we integrate negative sine x, you will get cos x. Number 3, you integrate secant x tangent x. Okay, you will get back the secant x. Okay, but usually in integration, we add the constant, the plus c, as you guys know already. Plus c here is a constant because it can be any number. Because if you differentiate any constant, you will get 0. So it doesn't have any effect here. So using this way, okay, what we can conclude is that as long as you have the list of formula for differentiation, you will have the formula for the integration as well at the same time. So all of this is the integration formula. So we will make use of this later on. Okay, what else that we have to discuss here? Again, coming back to the main question in this topic, the main things. So the main things, again, you want to integrate a function and you want to get a result. Okay. And as I mentioned before, our main focus is here. How to integrate everything will depend on our function here, fx. Okay, whether it is easy, whether it is complicated, sometimes easy, sometimes it is intermediate. Okay, sometimes it is complicated. Okay, depends. Okay, but our main thing is same. You want to get the result. If you have the limits here, let's say for example x2 until x3, you will get a number here. If you don't have, you will get in terms of functions. Okay, so integration, whenever you integrate certain function, there are two ways actually. To solve this, actually there are two ways. To get this number here, to get your result here, okay, to get the result of integration, okay, basically, okay, in the worlds of maths here, we can separate into two parts. There are two parts. Okay, number 1 is what we call as analytical methods. we call it as analytical method. Okay, basically this is the ones that we are going to do in this semester, in this subject here. And second is what we call as the approximate method. So we have two big topics. Again, what we want to do here, okay, we want to integrate. You want to integrate a functions and you want to get the result of your function here. Here, this is your objective. You want to get this. So there are two ways for us to do it. Number one is actually something that we call as analytical methods. Second is what we call as approximate method. Okay, what is the main difference between these two? The main difference is that analytical methods are going to give us the exact solution. Okay. Whereas for approximate method, they will give us, okay, as the name mentioned, approximate meaning that they will give us the approximate solution. Yeah. Okay, that's the two main difference between the analytical methods and approximate methods. So analytical methods, okay, this is the one that we are going to learn in this chapter. U substitution, integration by parts, okay, all of that belong under the categories of analytical methods. Approximate method, okay, you guys will learn it in UG later on, in the first year of UG. First semester or second semester, if I'm not mistaken. Okay, but why do we need the approximate method? Didn't we have the analytical methods that will give us the exact solution? Isn't that exact solution is much more preferred as compared to the approximate? Of course, we hope for the exact solution. That one is much more accurate as compared to approximate solution. But the approximate solution here is sometimes we are going to need it because, okay, because of what? Because certain function are not going to be able to be integrated. Okay, this come to the important thing. Why do we still have the approximate method? So you might think logically, right? Because we have the exact solution. Why do we need the approximate solution? Okay, number one reason, okay, because okay, not every fx here can be integrated analytically, or that's the reason. Okay. And this is a quite important disclaimer, okay, when we learn this topic. Okay, because you might wonder that, okay, like in differentiation, okay, whenever I want to give to you something like a quiz or test, etc., right? I want to ask you to differentiate this kind of function. When I can just quickly, okay, give you a function like a sine, inside sine I got tangent, inside tangent I got cos, and then I power 2, and then I divide by this, and then I square. You still can differentiate because differentiation just means that it is a gradient or the steepness, okay? So as we can still plot that kind of function and get the gradient at certain point. But okay, integration is quite different because integration will refer back to differentiation. As long as we have something on differentiation, we can have the integration. So that's why integration here, it is really difficult, okay? So whenever I want to give you some tests or whatsoever, I have to be really careful whenever we want to create a certain function, because not every function can be integrated analytically. So if that kind of function that cannot be integrated analytically, that give us the exact solution, so that's where we go to the approximate solution. Okay, although the approximate solution here is not that accurate, but that one is actually in the worlds of engineering or in the worlds of calculation, it is quite accurate enough. For example, analytical method that will give us, for example, the answer is 2. Approximate method will give us maybe here 1.99987, something like that. So it is actually
it's only a
quite,
matter of a few decimal places.
yeah, few decimal places only.
I see.
And there are many approximate method. Some approximate method might give you something like 1.97, something like this. Some approximate method will give you 1.999999. Okay, and it is actually doesn't have any effects. Very close to the exact solutions. Okay, you guys will learn back in UG, yeah, that one. I just give you the introduction right now. Okay, so let's go to the first part. Okay, continue. We have techniques of integration. Okay, coming back to technique of integration. Again, as I mentioned, technique of integration. Again, as I mentioned before, everything will based on the types of functions that you have. And because here we are focused on this analytical methods only. And we have a lot of analytical methods. Okay, not every analytical method is going to be covered. Okay, some will be covered in UG. This one is just a basic things. Okay, so when you want to actually solve the integration, so this might serve as well as your guidelines. When I say that based on your functions here, maybe it is just a basic function. Okay, when I say basic function here, it is something that you can use the formula directly. Under the categories of basic function, okay, whenever your fx here in the form of like a straightforward function. For example, if you want to integrate something like x squared, you want to know the result. So this one is straightforward. You can just integrate x squared. You will get 2x power 3 over 3. 2x power 3. X3 divided by 3. What else? Okay, still belong under the categories of basic function is something like something that need a little bit of algebraic manipulation. That one is still basic functions. Okay, what do I mean by algebraic manipulation here? Something like you have integration x times with x power 3, for example. Okay, so x times with x power 3 will give you x power 4. So you will have your answer x5 over 5, where you can just use your formula. Next, maybe here you have to use a little bit of trigonometric identities, substitution. You can see that, okay, maybe you have a function sine square plus cos square. You have to integrate sine square plus cos square. But if you remember the identity, sine square plus cos square is actually equivalent to 1. So you can just use the formula directly, actually. Okay, so that's what we mean by the basic functions. Okay, now if it doesn't belong into any of the basic function criteria, so this is where we have to upgrade our methods. Okay, we have to upgrade our methods. Second stage, in the first stage you have to check first whether your function here is a basic function or not. If it is, it does not belong into any of the basic categories, so you upgrade. Upgrade here, maybe we have to use some sort like substitution techniques. Okay, substitution techniques here is something like you have a function, okay, but when you substitute certain things into that function, it will become simpler enough where you can use the formula. Sometimes here you can use the substitution techniques. Okay, but U here, that one is the general. Every books are using the U substitution, but you can use A substitution, V substitution, Z substitution. That one is just a variable, so no problem. And even inside U substitution, you have to use more than one substitution. First, you use substitution, and then after that, you use again another substitution, and then after that, you use again another substitution. Okay, so that depends on the type of functions that you have. Okay, so this is like a second stage. If still couldn't be solved by using substitution techniques, maybe you want to upgrade again. maybe here we have to use the what? Number 3, coming to the integration by part. Integration by parts. Okay, so this is like a techniques again. Okay, but here you have to notice that even inside integration by parts also we can use actually at the same time the substitution technique. Okay, but this is like a third stage. First you look whether it is a basic function or not. If it is not, maybe you have to use the substitution techniques. If it is not, maybe you have to use the integration by parts. Okay, if it is not, again, number 4 here, we have other types of technique as well. Number 4, we have trigonometric integral. What else do we have? Okay, we can have here something like a trigonometric substitution as well. Okay, but trigonometric substitution is already been covered previously. Okay, we can have a partial fraction as well. Okay, and there are a lot more. Okay, but this is like some sort of like techniques, analytical methods that going to be covered in this subject. Okay, so this could serve very well serve as your guidelines. Happen? Okay, you look at your function first, and then check whether it is a basic function or not. After that, you can upgrade your techniques. Okay, because later on you might get confused. Okay, whenever you want to integrate, you might get confused. What kind of techniques that I have to use? Of course, if you do a lot of practice, then you will know already. So whenever you are given this kind of function, you will know. Okay, I have to use this technique. Okay, I have to use this technique. But as a starting point, to serve as your guideline, you might use this one. Okay, so now the basic formula. So let's start listing down the basic formula. I will list down the basic formula first, and keep in mind that every formula for differentiation can be used for the integration as well. We just have to reverse it. Okay, so the list of formula here will keep adding on and on and on. Okay, but right now I'll just focus on the basic thing first. So number 1. Okay, number 1 here, let's say we have a constant. You want to integrate the x. Okay, you will get x plus c. Okay. How do we get this formula? This formula coming from the differentiation. If you differentiate x plus c, which c is a constant, you will get back 1. C here is a number. Okay. Differentiate x, you get 1. Differentiate c, you will get 0. So number 2, what are the common formulas that we use? The polynomial formula xn, x power n, with respect to the x. So this will give us x power n plus 1 over n plus 1 plus c, except for negative 1. Negative 1, we have a different formula. So how do we end up with this formula? Okay, take directly. For example, if I want to differentiate x power 3 over 3 plus 4. Okay, so you differentiate x power 3 over 3 here, you will get 3x squared over 3. 3 and 3 cancel. 4 here will give you 0. So when you integrate x squared, you will get back x cubed over 3 plus 4. So simplify into number 2 here. That's how we get the formula. Number 3. Number 3, we have, for example, if k here is a constant. So if you integrate, for example, k times with fx, okay, you can bring out k outside and then you can integrate fx. This is exactly the same like differentiation. Differentiation, if you want to differentiate 2fx, it is the same as you bring 2 outside and then you differentiate that function. And then after that, you multiply back with number 2. Same thing. Integration also the same. Okay, what else do we have? Number 4. So number 4, we have, okay, for 2 or more function, we can have, for example, integration fx plus with what? Gx plus with what? Hx. After h what? I. Ix. Okay. You can continue if you want. Okay, you can here separate. Integrate fx. Integrate gx. Integrate hx. Integrate ix. Okay, individually. Not only plus, we can have minus, 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 minus as well. Okay. So if you look at the patterns, okay, it is also like the same way like what we did in differentiation. Differentiation, in the basic formula for differentiation also we differentiate constant, we get what? Differentiate polynomial, we get what? If we multiply with constant, what can we do with that? If we want to perform the differentiation for the addition of several functions, also we have that, right? For differentiation. Integration also we have. And if you remember, we have the composite functions in differentiation, where we call it as the chain rule. Okay, if you remember. And we have the product rule and quotient rule in differentiation. Okay. In integration, we don't really call it as chain rule. We don't really call it as a product rule or quotient rule. We have something like the U substitution. The techniques that I listed before, U substitution here. Okay, this is comparable to the chain rule in differentiation. In differentiation, we call it as a chain rule. In integration, we call it as a U substitution. It is like something like that, okay, slightly different. Product rule in differentiation. In integration, we have something similar, okay. We call it as integration by parts, okay. So in some way, okay, integration and differentiation here, they are the same, okay, but a little bit of arrangement, obviously. Okay, so this is the basic things about the differentiation. Okay, so now before we start, okay, let's start first with some easy things. Okay, just to get you start. Example, so you might want to do it. Okay, I'll give you here just to get started. So integrate 1 plus 2x minus 4x cubed with respect to dx. Okay, B, integrate 3x minus 2 over square root x with respect to dx. C, integrate here sine theta plus sine theta tangent square theta over secant square theta, okay, d theta. So all of this is a basic function. Still belong under the categories of basics. Here, basic function. So, guys can try first.
Okay.
3 minutes. Okay, enough? Simple je ni. Okay, done? Finish.
Yeah.
Okay, finish already. So everything good, sir? Easy, Easy, right?
Hopefully, yes.
Hold on a second. I'm still typing it into.
Easy, easy.
Okay, I'll try to do it just for the sake of keeping the notes here nicely.
Yes, please.
A, simple. So I'll write the solution exactly. So here you can actually integrate 1 plus integrate 2x minus integrate 4x cubed, right? So x square over 2 plus 2x power 3, 2x power 3 pula. 2x power, ni kenapa x square? 1, right?
1. Yeah.
2x square over square minus here 4x power 4 over 4. Then at the end you plus c. Okay, although you integrate 1 by 1 here, integrate 1, integrate 2x, integrate 4x cubed, you don't have to every single time you integrate 1 you add plus c here. Integrate 2x you add plus c, you add 4x cubed you add another plus c. Then only at the end you add plus 3c. 3c, 2c, 100c, okay, 1000c still constant. When you differentiate a constant, you still get the 0. So you might just want to simplify everything and just write down the c after you finish everything. Okay. B here still simple. B here you can just separate into two parts. Integrate 3x. This is 1 over 2.
Minus integrate 2.
2x 1 over 2.
Yes.
This one you guys can combine, right? This will give us 1 minus 1 over 2 will give us 3 over 2, right?
Yeah.
1 over 2. 1 minus 1 over 2.
Yes, 1 over 2.
Okay. Integrate. This one also integrate, become 2x minus 1 over 2.
Yes.
Okay, so this will give us 3x 3 over 2 because 1 over 2 plus 1 divided by 3 over 2. This will give us minus 1 over 2 plus 1 is 1 over 2.
1 over 2.
And divide by 1 over 2. And at the end, you plus c. Okay, if you want to simplify that one, is okay lah. Okay, so one thing that I want to mention here, because if we focus on our cost outcome, actually, the simplify, okay, some of you might actually be specific with the simplify, so I don't really bother too much about the simplify. We just focus on the techniques, how you integrate. As long as you can integrate, I won't bother so much about the way that you simplify your answer. If you want to simplify, that's good lah. Okay, but as long as you can integrate, that one is enough already. Okay, C is what? C is sine theta. Okay. C is sine theta plus sine theta tangent square theta over secant square. Okay. So here, you guys can factor out sine. Become 1 plus tangent square theta over secant square theta. Okay. And 1 plus tangent square theta here, this is actually equivalent to secant square theta. And secant square theta here can be cancelled out. And you just left with sine theta d theta. And sine theta d theta here is actually equivalent to negative cos, right?
Negative cos.
Yeah, negative cos theta d theta. How do I get this? Because coming from the formula of differentiation. If you differentiate d dx sine x, you are supposed to get cos x. And then from here, you integrate cos x, you will get sine x. If you differentiate d dx cos x, you will get negative sine x. So from here, if you integrate negative sine x, you will get cos x. If we want to integrate sine x, you just have to factor out negative outside here. And you just have to bring the negative to the side. So sine x is equal to negative cos x. So that's how I get this one. This coming from the list of formula. And 1 plus tangent square theta here. Okay, that one is the trigonometric identities. Okay, just to remind you, sine square plus cos square is equal to 1. If you divide everything by, this is the second variation. Divide everything by cos. You will get, this will give us tangent 1 over cos is secant square. This is the second variation, trigonometric identities, basic trigonometric identities. So actually we have a special topics for integration by using a trigonometric identities, but that trigonometric identities is something like a a complicated trigonometric function, but this one is just a simple trigonometric function. That's why it belong under the categories of a basic function, where you can just do some algebraic manipulation and then just use the formula. Okay, so this is all the basic things, okay, until here. Okay, so since this is our first class, when is our next class? Is it on Thursday?
Yes,
or
our next class
tomorrow?
is on Thursday.
Oh,
10
our
to 12.
next class is on Thursday.
Yes, tomorrow, public holiday, sir. Malaysia Day.
Yeah. Oh, yeah, correct. Tomorrow is holiday. Malaysia Day.
Yes.
We forgot about that already.
Of course not, sir. We Malaysians remember our holiday always.
Yeah, of course I remember. Okay. So I'm thinking that maybe we can end our class already. So we can end our class already. So before we end our class, do you have any other question?
Okay, sir. About
Okay.
the course assessment, let's say there is a final, so meaning our coursework will be 50%, or how much percent will it be?
50%, brother.
That one we are still not sure yet. Maybe we can retain still 70%, or maybe there is a chance that it will be converted to back to 50%. So that's why I couldn't say anything yet, okay? Because it haven't been confirmed by the Senate. So we have to wait from them. But right now we still using the 70-30 right now at the moment.
That's good.
Yeah.
At the moment 70-30, but let's say something go they want us to use the final exam, maybe retain 70-30 or maybe go back to 50-50. We are not sure yet.
Oh,
Okay,
okay, so-
everything depends on the Senate.
Mm.
But 70-30, you guys easier, right? Just score.
Yes.
You prefer consistent work rather than rush at the last moment.
How's your performance last semester? Is it okay?
Pretty good, I would
So,
say. I think
For coursework,
for coursework, yes. For EA, we have no idea.
we have to wait
But your result haven't been published, right?
No, for EA, no.
maybe 29th this month.
Yeah, 29 September, it should be released.
I know your result actually, but I couldn't. Of course, I know your result because I'm in the vetting session with your lecturers as well. But of course, I couldn't disclose the information.
A little bit of insight.
Well then, sir, tell me as a whole, is mechanical engineering worthy?
No, I can't say anything.
Just a little bit, sir, not just a little bit, no?
Yeah?
A little bit of hint, like, are we alright? Or are we trash?
I'm not sure about your specific group, but the overall, I know for overall.
Overall, like the whole foundation?
The whole foundations.
Oh, so
It's
okay.
not only your groups. I know the rest of the groups. Okay, I think quite good. It's quite good. It's quite good.
Hey, okay, that's exciting.
I'm not saying that it's poor or what, but everyone's result is quite good.
I see.
That's good now.
So we must wait for the Senate to make
Yeah,
the
you
decision.
have to wait for the Senate result. Okay, because we cannot say anything. We cannot publish your result.
The Senate is absolute, I see.
Yeah, the absolute, the power. We don't have anything.
The dictatorship of UTP.
I'm just coolie here. Okay,
So did we
anything else that you want to ask me?
So
I
did we
don't
all
think so.
pass?
What?
Did we all pass our results?
I'm pretty sure. I mean, if you don't pass, you can kill yourself. Now I'm joking.
I
hope
mean,
so.
our coursework is 70%, so safe to say we already passed that.
Actually, yeah.
Yeah.
You
Okay.
would have to be really bad to fail.
70%, if you score quite good in your coursework, so chances for you to get an A actually is quite high.
Yeah.
As long
3.5
as long
above.
as your coursework is high lah.
Yeah, you can manage to get 3.5 above if you score coursework.
I mean,
I think
coursework is
to
a
get-
huge advantage already.
Should get at least B is nothing lah. You for sure you can get B's lah.
Nice.
Unless you perform really poorly in EA, I'm not sure. Okay, then there are cases where you couldn't score.
Alright.
But of course, you do something right for EA, right?
Yes.
It's not that difficult, right, for EA.
Not difficult but tedious.
Yeah, it's a bit tedious
Yeah.
because it is open-ended, and it will be much more tedious for the maths too.
Oh, no. It's okay.
It's much more tedious in maths too.
We have
Yeah.
seen what it was like. Now we prepare for the next one.
Mentally prepared, that is. Just
Physically as
mentally
well.
prepared.
Yeah, you have to
Mostly-
mentally prepare. but it is online, so assignment, and I think you guys have all
A lot
kind
of
of resource with you, so I think
yes.
it shouldn't be a problem. If in final, if you are in close place, then I think it will be much more difficult, sir.
Well, then
But
we are
the question
engineers.
will be more direct lah. That's the difference.
Modern problems call for modern solutions.
Yeah. Yeah, that's right. That's right.
This is our job as engineer.
Okay. Anything else?
I think
I think
that is all
that's
for
about it. Anyone else want to ask questions?
Anyone else? Okay. Where are the rest? I
If your
couldn't
mic-
hear your voice.
If your mic is broken, you can type in the group chat. I'll say something for you.
Thank you, sir.
Oh, thank you, terus.
There's the class people.
Sorry.
Nikita.
Yeah, again with her screaming.
Hey, at least-
Nikita is international student, no? It's a local student.
international student.
No.
No,
Oh.
no, I'm not.
Where's? Did you speak, Nikita? Is that you, Nikita?
Yes, yes.
Oh, okay. Because I just
Sorry.
could see that the Mirza, Amni, and Yan on the screen right now. I couldn't see everyone. That's why lah.
That was my brother. This is me, Nikita. Now.
Oh, okay. Who's your brother?
Oh, my brother is just annoying me. He's here. He's not in UTP.
Oh, he's not in UTP. I thought he's in UTP. Because Nikita, I've got one of my students named as Nikita as well. So that's why I wonder whether he's related with you.
Twin?
No.
There's another person
Okay.
with the same name.
So you are local. I thought international student.
Yes.
Okay. Where are you from?
Malaysia.
No, I mean from the state. Which state? I know lah. You
Yes.
said local. Of course, Malaysia already.
Obviously.
I'm laughing so badly, you know.
Huh? From where? Nikita,
Malaysia.
from where, Anita?
Shah Alam.
Oh, Shah Alam. Okay. So you are on campus, right now?
No, I'm not.
You are not on campus.
No, none of us are on campus.
Everyone here is at home because we are kicked out from UTP. Only next May we're coming back.
Oh, okay. I thought everyone on campus right now. No,
No. We are
Yeah.
coming back
Because
next month.
the new September intakes will be going in this month.
They're
So
already in,
you'll
Mirza.
be-
They're already
I
in.
know. They are in. Just to maintain
Okay,
the-
but some students are already coming in, right? I
Yes.
mean from several states. The one from Kedah, I think they went for quarantine at V6.
Yeah.
Yeah, for Kedah people.
Oh, for
Already.
Kedah.
Yeah, for the
Saya orang Kedah kat
they
ni
have-
kampung saya kena.
Oh yeah, we should probably stop the recording, shouldn't we? The class technically is over already.
Yeah, correct.
How do we stop the recording?
No.
Oh yeah, I'm the one
I'm
that's-
reminding sir.
Okay, now it's saved.
Time to chat.